Hi children, so today we are going to see what nuclear forces are or strong force are. Okay, so in this chapter we have already seen what a nucleus is composed of and what are the type of particles which are present inside a nucleus, and it is a general term uh, referred to as nucleons, which is a collective term given to neutrons and protons. Now we know that the nuclear density is very high, of the order of 10 raised to 17 kilogram per meter cube, approximately 10 raised to 17 kilogram per meter cube, and it is almost the same for all the almost no it is the same for all the elements present in the nature or in the universe. So what actually accounts for this high density of a nucleus? We know that the particles which are present inside the nucleus are so well packed or very tightly packed within a small space. So how are they managing to stay so close to each other, apart from or despite the fact that there will be electrostatic force of repulsion between the protons? Because we know that protons and neutrons both constitute the nucleus. So protons which are positively charged, when they are so close to each other, there should be some kind of force, a very large electrostatic repulsion between them. But when you consider this force alone, then a nucleus won't be able to stay like that with the protons very close to each other, or the nucleus will fly apart or split into the corresponding nucleons. But that is not happening. So that gave the idea that apart from this force, which is the electrostatic force, there is another kind of force which is operating within the nucleus, which is known as the strong force or the strong nuclear force. And when we consider the strong force or the nuclear force, we have to know about its properties. The first thing, we have already learned or we have already seen what mass defect is. That is, when during the formation of a nucleus, there some mass disappears during its formation, and this mass which has been disappeared will appear as the binding energy, which is considered as the binding energy of the nucleus. That is, that it is very tightly bound, the nucleons are very tightly bound. That means you will have to supply an additional energy or an energy which is equal to its binding energy in order to split a particular nucleus into its corresponding or constituent nucleons. So if they are so well bound, that means the force which is keeping them together should also be very large. So when you we have so far known about the gravitational force and the electrostatic force. Both are conservative and central forces, and also they obey inverse square law. These are the three basic properties of gravitational force as well as electrostatic force. And as these nucleons have a mass, there should be gravitational force among them, but that is very weak. When you consider the electrostatic force, again, that is much larger than the gravitational force, of the order of 10 raised to 36 times. It is larger than the weak gravitational force, but they are very these charges are at very small distance. The electrostatic force of repulsion operates, or it has a an appreciable value. But despite this repulsive force, it is not moving apart, or they are managed to stay stable inside a nucleus. The reason is that there is a force which is 100 times stronger than this electrostatic force, which is the strong force. So it is actually 10 raised to 38 times the force when compared to gravitational force. These both are compared with the gravitational force. The first one is actually the electrostatic force. The second one is the nuclear force. So when you compare these two with the gravitational force, you can see how weak the gravitational force is, and the nuclear force is considered as the strongest.